Hi, I'm Kelly Sotak, and I'm a PhD student in Dr. Stein's lab. Today I will be discussing prediction of concentrations of digestible, metabolizable, and net energy in soybean meal from throughout the United States fed to pigs. I'll begin by introducing the soybean analysis that were performed on the soybean samples. Then I will go into the composition of the soybean meal sources, discuss DE, ME, and NE concentrations, and draw overall conclusions. The objective of this study was to determine the in vivo digestibility of energy and concentrations of DE, ME, and NE in soybean meal fed to growing pigs. We used one single batch of corn and 22 different sources of soybean meal. And these soybean meals were from 4 different growing zones. Zone 1 was the northern United States and included South Dakota, Minnesota, and Michigan. Zone 2 was the Eastern Corn Belt and included Ohio, Indiana, and Georgia. Zone 3 was the Western Corn Belt and included Nebraska, Missouri, and Iowa. And Zone 4 was Illinois. To further break down the different soybean meal samples, Zone 1 had 1 soybean meal sample from Michigan, 2 from Minnesota, and 1 from South Dakota for a total of 4 soybean meal samples. Zone 2 had 1 soybean meal sample from Georgia, 3 from Indiana, and 2 from Ohio, for a total of 6 soybean meal samples. Zone 3 had 3 soybean meal samples from Iowa, 2 soybean meal samples from Missouri, and 2 from Nebraska, for a total of 7 samples, and Illinois had 5 soybean meal samples. The corn and soybean meal were analyzed for gross energy, dry matter, crude protein, ash, ADF, NDF, lignin, and acid hydrolyzed ether extract, amino acids, calcium and phosphorus, and starch. The soybean meal samples were analyzed for trypsin inhibitors. The feces and urine were analyzed for gross energy, and the diets were analyzed for gross energy, dry matter, crude protein, ash, ADF, NDF, and lignin. We used 23 growing barrels that were approximately 26.4 kilograms and were allotted to a 23 by 8 Uden square with the 2 blocking criteria of pig in period. We used the marker-to-marker approach for the feces, and each period was 14 days, with the first 7 days as an adaptation period and the last 7 days as a collection period. Urine was collected in buckets over 50 milliliters of 3N hydrochloric acid that was used as a preservative, and we collected 20% of the samples daily. Feces were mixed with water and subsampled, and the urine and feces subsamples were lyophilized and finely ground prior to analysis. DE was calculated by subtracting the energy found in feces from the gross energy. Metabolizable energy was calculated by subtracting the energy found in urine from the DE, and NE was calculated using an equation from the 2012 NRC that used the components of metabolizable energy, ether extract, starch, crude protein, and ADF. This shows the ingredient composition on an as-fed basis. At the top we have corn and soybean meals from zones 1, 2, 3, 4, and the average of all 4 soybean meals. The GE of corn was 3,965 kcals per kilogram, and the average soybean meal gross energy was 4,184 kcals per kilogram. There were no differences among the 4 zones in terms of gross energy. The crude protein of corn was 9.52%, and the average soybean meal crude protein was 47.41%. There was an increase in crude protein for the soybean meals in Zone 2 and Zone 4 compared with the soybean meal in Zone 3, however, it was not different from the soybean meals in Zone 1. The average ash concentration of corn was 1.36%, and the average soybean meal ash concentration was 6.91%. There was an increase in ash concentration for soybean meals in Zones 1, 3, and 4 compared with Zone 2. The average trypsin inhibitor units for soybean meal was 3.29 milligrams per kilogram, and there were no differences in trypsin inhibitor units among the 4 zones. The calcium concentration of corn was 0.01%, and the average calcium percentage for soybean meal was 0.38%. There was a tendency for an increase in calcium for the soybean meals in Zone 3 compared with the soybean meals in Zone 1 or Zone 2. The phosphorus concentration of corn was 0.23%, and the average soybean meal phosphorus concentration was 0.65%. There were no differences among the soybean meals in all 4 zones. This shows the composition of the diets on an as-fed basis. The corn diet contained 96.78% ground corn and 3.22% vitamins and minerals. The corn-soybean meal diets contained 71.25% ground corn, 26% soybean meal, and 2.75% vitamins and minerals. Moving into the results. I'd like to take a moment to set up my slides. The red bar indicates the corn. The yellow bar indicates the Zone 1 soybean meals. The blue bar indicates the Zone 2 soybean meals. The green bar indicates the Zone 3 soybean meals. The purple bar indicates the Zone 4 soybean meals. And the orange bar indicates the average of all 4 zones. The ATTD of gross energy for corn was 86.1% on a dry matter basis, and the average ATTD of gross energy for the soybean meals was 90.89%. There were no differences in ATTD of gross energy among the 4 zones. The DE of corn was 3,834 kcals per kilogram of dry matter, and the average DE of soybean meal was 4,261 kcals per kilogram of dry matter. There was a decrease in DE for the soybean meals in Zone 3 compared with the soybean meals in Zone 1 or Zone 2. However, it was not different than the DE of the soybean meals in Zone 4. The ME of corn was 3,699 kcals per kilogram of dry matter, and the average ME of soybean meal was 4,044 kcals per kilogram of dry matter. There was a decrease in ME for the soybean meals in Zone 3 compared with the soybean meals in Zone 1 or Zone 2. However, it was not different than the ME of soybean meals in Zone 4. The net energy of corn was 2,699 kcals per kilogram of dry matter, and the average NE of soybean meal was 2,900 kcals per kilogram of dry matter. There was a decrease in the calculated net energy of the soybean meals in Zone 3 compared with the soybean meals in Zones 1 or 2. However, there was no difference from the soybean meals in Zone 4. We did show a decrease in energy values for the corn used in this experiment. However, there was a decrease in fat concentration of about 1.6% compared with NRC values. We also saw almost a 3.5% increase in NDF compared with the 2012 NRC values, which would have resulted in a decrease in the energy concentrations. Therefore, we do not believe that the energy concentrations of the corn used in this experiment were underestimated. This shows the DE and the ME of soybean meal. First, we have the 1998 NRC, which had DE as 4,140 kcals per kilogram of dry matter, metabolizable energy 3,797 kcals per kilogram of dry matter, net energy at 2,694 kcals per kilogram of dry matter, and an ME to DE ratio of 92%. The 2012 NRC has DE at 4,022 kcals per kilogram of dry matter, metabolizable energy at 3,661 kcals per kilogram of dry matter, net energy at 2,623 kcals per kilogram of dry matter, and the ME to DE ratio of 91%. 6 experiments conducted at the University of Illinois between 2010 and 2012 showed DE to be 4,347 kcals per kilogram of dry matter, metabolizable energy to be 3,980 kcals per kilogram of dry matter, net energy to be 2,968 kcals per kilogram of dry matter, and an ME to DE ratio of 92%. This experiment again found the DE to be 4,261 kcals per kilogram of dry matter, metabolizable energy to be 4,044 kcals per kilogram of dry matter, net energy to be 2,900 kcals per kilogram of dry matter, with an ME to DE ratio of 95%. This shows that the results in this experiment are in line with results from previous experiments conducted at the University of Illinois, and therefore the NRC may underestimate the energy value of soybean meal. In conclusion, soybean meal from throughout the United States contains similar concentrations of most nutrients and anti-nutritional factors. However, crude protein was decreased for soybean meals from Zone 3. Regardless of growing region, GE, DE, ME, and NE were similar for soybean meal from the northern, eastern, and southern United States, but were decreased for soybean meal from the western United States. And again, DE, ME, and NE may be greater in soybean meal than reported by the 2012 NRC. And with that, I thank you for your attention. For further information, please visit our Monogastric Nutrition Group's website.